Hi, so today's lesson was about choosing the best method. This is for solving systems of equations, which just as a reminder is when I solve two equations at the same time and I'm solving for x and y. And in class we've really focused mostly on three different methods, and those three methods are graphing, substitution, and elimination. Now you can really solve any system of equations using any of these methods, but depending on how the problem is given to you and kind of just some key parts of it, sometimes a certain method might be easier or more efficient than using a different method. But if you did them all correctly using any of those methods, you would get the same answer for any type of problem. So let's just talk about some of the key features or the kind of like things that stick out in a system of equations to help us know which kind or which method is the most appropriate for that system. So for graphing, there's a couple of things that we want to look for. The first thing is, ideally we want both equations to be in y equals mx plus b form. This is called slope-intercept form because m is the slope and b is the y-intercept. And if both equations are in this form, it's already set up for me to graph. I can start at the y-intercept and then follow the slope to create the line. And the place where the points cross, where the lines cross, is the answer or the solution to that system. Some other things that we might want to look for is if there's fractions. So a lot of times slope comes to us in a fraction, like 1/3 x or -2/7 x or whatever it happens to be. If the slope is a fraction, it's a lot easier to graph a fraction than it is to solve a problem with a fraction in it for most of us, unless you love fractions. Okay, so those are a couple things that we look for. And the last thing that we look for is we also look for smaller numbers, because if the numbers are really, really big, like in the 20s or 30s or even bigger, it's going to be really hard to graph that. So if they're big numbers, sometimes it's easier to use another method. But again, you could also solve it by graphing. When I am solving by substitution, usually what will happen is one of the equations might look like standard form, which is kind of having the x and the y's on the same side. But the other equation has to have a variable isolated. So for substitution, usually the giveaway is that one equation has a variable isolated. And that's basically the mathy way of saying one of my equations says either x equals all the other stuff, like 2y minus 7. So see how the x is by itself, x equals. That's what we're looking for. So if one of the equations has a variable isolated, either x or y, I'm probably going to want to do substitution, because what you do is you take what it equals and you substitute that into the other equation for x. So that's pretty much the giveaway point for the substitution. And then lastly, elimination is when everything is lined up. So we're going to talk about kind of a tricky looking one here in a minute. But by everything, I really mean everything, because you need to have your x's lined up, your y's lined up, your equal signs have to be lined up, and just the plain numbers, those are called constants, those have to be lined up as well. So it's super important that you notice that everything is lined up. And the goal for elimination is to cancel out a variable or eliminate a variable, which is why it's called elimination. That's pretty cool. All right, here's our first example. We're actually not going to be solving these in this video because we have other videos for that. The goal of today's video is just to help you be able to identify what method is the best and then be able to justify or explain that. So when I look at this problem here, I see that the x's are both lined up, the y's are lined up, the equals are lined up, and the constant terms are also lined up. So because everything is lined up, I would say that elimination is the best method for this system. To justify my reasoning, I would say because everything is lined up. I would also say, and the y's, or the two y's, the negative 2y and positive 2y, eliminate. So they go away because negative 2y and positive 2y makes 0. And then I can solve it from there. Here's my next example. So it looks to me like the x's are lined up. It kind of looks like the y's are lined up and the numbers. But I am hoping that you notice, this is a tricky one I was talking about, that the equal signs are not lined up. So this would not be an elimination method because the equal signs are not lined up. So the next thing I'd like you to notice is that in this second equation right here, I have x by itself. I have x equals this whole expression. X is isolated. So the appropriate method for this system would be substitution. And to justify, you would say because x is isolated in one equation. And I can substitute that expression 2y plus 4 into the other equation for x. So that's what it's called, substitution. Here's my next one. So this one looks pretty different from the last one, so let's talk about that. Notice that they both have y isolated here and here. And not only that, they're both in y equals mx plus b form, which is called slope-intercept form. So this one is really great to use for graphing. And to justify my reasoning, I would say because both equations are in slope-intercept form, or y equals mx plus b form. I would also say for this one that the slope of the first one is a fraction, and it's going to be a lot easier to graph 1/3 than it is going to be to solve an equation with 1/3 in it. So I'm going to add that down here. And the 1/3 slope would be easier to graph than solve. Oops, I forgot the b, would be easier to graph than to solve. Okay, here's our last one. Go ahead and take a look at that one. I want you to think about what method do you think would be best for that system. Have an answer ready and a reason for that. And I'm really hoping that you notice the first equation has y isolated, because you can plug it in down here for the y. And when I have an equation with one variable isolated, the answer should be substitution. Good job. And I'm going to use substitution when I have a variable isolated in one of the equations. Thanks for watching.